Hi, welcome back to my channel. My name's Gina. In this video, we'll look at 3 more derivative rules: the product rule, the quotient rule, and the chain rule. If you want to review the other derivative rules, I'll put the link up there. So let's do a quick recap. So far, we've only looked at one derivative formula, the power rule, which states that if a function is of the form x to the power of r, where r is any real fixed number, then its derivative equals to r times x to the power of r minus 1. And we've looked at several derivative rules. The first one, constant function rule, which states that if a function is a constant, y equals to c, then its derivative equals to 0. And then we've also looked at the constant multiple rule, which states that if a function equals to a constant times a function of x, for example, y equals to c times f of x, then derivative of y is the constant c times the derivative of f of x. And then we've also looked at the sum and difference rules. For example, if y equals to f of x plus or minus g of x, then derivative of y is simply the derivative of x plus or minus derivative of g of x. And similarly for the difference rule, derivative of y is f prime minus g prime. Now let's look at 3 more rules. The product rule. If a function is f of x times g of x, then unlike the sum and difference rules, the product rule is a little bit more complicated. So if a function is defined by the product of 2 functions, then y prime equals to the derivative of the first function times the second function plus the first function times the derivative of the second function. And for the quotient rule, if a function is defined as a function of x over another function of x, then its derivative is again more complicated. Its derivative is derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the denominator square. And lastly, there's the chain rule, which states that if a function is a composition function, which means that the input of a function is another function. For example, y equals to f of g of x. So the input for f of x is another function, g of x. Then its derivative equals to the derivative of f of x, where the input is still g of x, times the derivative of the inside function, g of x. Now let's look at some examples. First one, y equals to 2x squared times 3x cubed. So here we have a function of x times another function of x. So we'll need to use the product rule. So y prime equals to the derivative of the first function, which is 4x, times the second function, which is 3x cubed, plus the first function, 2x squared, times the derivative of the second function, which is 9x squared. And we can rewrite this as 12x to the power of 4 plus 18x to the power of 4, which equals to 30 times x to the power of 4. Now let's look at the next example. Y equals to 2x over x minus 1. So here we have, in the numerator is a function of x over x minus 1, which is another function of x. So here we need to use the quotient rule. So y prime equals to the derivative of the numerator, which is 2, times the denominator, x minus 1, minus the numerator 2x times the derivative of the denominator, which is 1, over the denominator square. Now let's simplify this. So this equals to 2x minus 2 minus 2x over x minus 1 square. And the 2x can cancel out with the negative 2x. So this equals to negative 2 over x minus 1 square. And then the third example, y equals to x plus 1 times x squared minus 3 over x plus 2. So in the numerator, we have a function of x times a function of x, and the denominator is another function of x. So here we need to use the product and quotient rules. You can actually look at this function in different ways. So you can think this function as a function in the numerator over x plus 2. So in this case, you'll use the quotient rule first. Or you can think this as x plus 1 over x plus 2 times x squared minus 3. In this case, you'll use the product rule first. But in either case, you'll need to use both the quotient and product rules. So here I will show you how to use the quotient rule first. So y prime equals to the derivative of the numerator times the denominator x plus 2 minus the numerator times the derivative of the denominator, which is 1, over the denominator square, which is x plus 2 squared. So now we still need to solve for the derivative of the numerator. So in the numerator here, we need to use the product rule. So the first function is x plus 1, and the second function is x squared minus 3. And the product rule says this derivative equals to the derivative of the first function, which is 1, times the second function, x squared minus 3, plus the first function, x plus 1, times the derivative of the second function, which is 2x. Then we can continue the rest of the equation. So this times x plus 2 minus x plus 1 times x squared minus 3 over x plus 2 squared. Now let's look at two examples using the chain rule. So the first example, we have y equals 2x plus 1 to the power of 5. So this looks like the power rule, but instead of x to the power of r, now the x is 2x plus 1. So we can write the y as a composition function, where f of x is x to the power of r, and g of x is 2x plus 1. So y is f of g of x. Now let's use the chain rule. So the chain rule says derivative of y equals to derivative of f, where the input is g of x, then times derivative of g of x. So f of x is x to the power of r, so we can use the power rule. So the first term here, f prime is 5 times, and the input is g of x, which is 2x plus 1, to the power of r minus 1, which is 4. Then times derivative of g of x, which is 2. So in summary, y prime equals to 10 times 2x plus 1 to the power of 4. Now let's look at another example. Here we have 2x plus 1 squared times x squared plus 6 cubed. So here we have a function of x times another function of x. And for each function, Now we have to use the chain rule version of the power rule. So y prime equals to the derivative of the first function 2x plus 1 squared prime times the second function 2x plus 6 cubed, then plus the first function 2x plus 1 squared times the derivative of the second function x squared plus 6 cubed. So now we use the chain rule to the derivative of the first and the second function. So for the first function, we have f of x is x to the power of r, and r equals to 2. And the inside function is 2x plus 1. So its derivative is 2 times the inside function, 2x plus 1 to the power of 1, times the derivative of 2x plus 1, which is 2. Then we continue the equation times x squared plus 6 cubed plus 2x plus 1 squared. And the second derivative is also a composition function. And the outer function is x cubed and the inner function is x squared plus 6. So we use the chain rule to get its derivative equals to 3 times the inner function 2x plus 6. And the exponent is 3 minus 1, which is 2. And then using the chain rule, so we need to times the derivative of the inner function, which is 2x. So now let's simplify the answer. So y prime equals to 4 times 2x plus 1 times x squared plus 6 cubed. Then plus 6x times 2x plus 1 squared times x squared plus 6 squared. If you have any questions, feel free to comment below, and I'll see you in the next video.